Hello everyone. In this tutorial, we'll discuss the learning objectives from 9.4 to 9.8, which is part of the requirement for system-wide quiz in term 3. This part is about different types of chemical reactions. In the KPI 9.4, you are going to learn how to write balanced equation, complete ionic equation and net ionic equations, and word equation for reactions that involve formation of a precipitate. In order to do that, you should be able to use the solubility rule. If you dissolve, for example, soluble salt of silver nitrate with sodium chloride. Silver nitrate is a soluble salt. Once you put it in water, it's going to dissociate into positive silver ions and negative nitrate ion. So by looking here, you should distinguish that these positive ions are for silver and those negative ions are for nitrate. Remember, nitrate is NO3. Nitrate salts are negative and silver salts are positive, but in water they get separate. That's why the solution seems clear or colorless. But if a precipitate is formed, the precipitate here will be silver chloride, AgCl. It's insoluble salt, so they are going to stack together both positive and negative ions. You should be able to use this solubility table. Lithium, sodium, potassium, and ammonium are all soluble, and no exception. Nitrate and acetate. And sometimes we can call them ethanoate salts are soluble. Chloride, bromide, iodide are soluble. When these ions pair with silver or mercury or lead, they will form insoluble salt. This means that silver chloride is insoluble. Mercury chloride or bromide or iodide are insoluble. Lead chloride, bromide, iodide are insoluble. Sulfate. Sulfate, normally they are not soluble. Especially if you have sulfate with strontium, barium, lead, and silver, or calcium. So calcium sulfate is insoluble. Strontium sulfate, barium sulfate, lead sulfate, and silver sulfate, they are all insoluble. Here, hydroxide and sulfide. Hydroxide and sulfide are generally insoluble. Exception, lithium, sodium, potassium, and ammonium, because we have said here that all lithium, sodium, potassium, and ammonium are soluble. So if I have lithium hydroxide, it will be soluble, or sulfide. When sulfide pair with calcium, strontium, barium, also they form insoluble salt. So if we say calcium sulfide, barium sulfide, or strontium sulfide, they are all insoluble. When hydroxide pair with calcium, strontium, or barium, the result is slightly soluble. So calcium hydroxide is slightly soluble. Carbonate and phosphate. When these ions pair with lithium, sodium, potassium, or ammonium, the result will be soluble salt. So normally carbonate and phosphate are insoluble, except lithium, sodium, potassium, and ammonium, carbonate, and phosphate. They will be soluble. Looking at the solubility rule, you will distinguish that compounds containing sodium ions are soluble. Sodium ions are soluble. That means that such as sodium bromide, sodium nitrate, sodium sulfate, sodium hydroxide, sodium carbonate, they are all dissolved in water and form solutions. Compound that contain nitrate, because also all nitrate salts are soluble. So compounds that contain nitrates are soluble. silver nitrate, lead nitrate, sodium nitrate, calcium nitrate, strontium nitrate, they are all soluble in water. Compounds containing carbonate, they are insoluble because here this part is for the salts that are generally insoluble, but this part is for the compounds or the ions that are generally soluble. Therefore, compounds containing copper carbonate, calcium carbonate, strontium carbonate, iron carbonate are all insoluble. But there are some exceptions for carbonate. Okay, because looking here, these are the exception part. Lithium, sodium, potassium, ammonium, carbonate, and phosphate are soluble. Okay, so when carbonate is paired with lithium, sodium, potassium, ammonium, they will form soluble salts. Let's try to solve these questions. Predict whether each compound is soluble or insoluble. Nickel sulfide. If you go back to the solubility table, you will find that nickel sulfide is insoluble. Look here, nickel sulfide. What's written here? Sulfide are generally insoluble. So, and a nickel is not in the exception. This means that nickel sulfide is insoluble. Next, we have magnesium phosphate. Going to the solubility table to look for the phosphate. Yeah, phosphate is insoluble except lithium, sodium, potassium, and ammonium. So magnesium is not in the exception. This means that magnesium phosphate is خلص. Suppose you have a question asking, determine whether each compound is soluble or insoluble, and then list ions present in solution. And he is giving you some examples. AgNO3, B, PbC2H3O2 O2 C KNO3 D NH4 2S. Okay. Silver nitrate, soluble or not? Going to the solubility table, you will recognize that all nitrates are soluble, so this is a soluble salt. If you say soluble, list the ions present in solution. It has silver positive ions and the nitrate negative ions. Lead acetate. What are the ions present in solution? First, it's acetate of lead. Let's go to the solubility table first. Here is the solubility table. Okay, the question is lead acetate. Okay, here is the acetate. Acetate salt is soluble and no exception. So lead acetate is a soluble salt. Okay, and if it's a soluble salt, it will make ions. So the ions will be lead ions and acetate ions. How to know the formula? Lead, here the valency of lead is 2. And what is the valency of acetate? You will get the valency of acetate from here, it's 1 minus. So the other ions present are acetate ions that are negative. KNO3, okay, potassium salts. Yeah, potassium salts are soluble with no any exception. So this is going to make a soluble salt, potassium positive ions and nitrate negative ions. To know the formula, go to the solubility and look carefully. You will find that nitrate is -1. Ammonium sulfide. Looking here, ammonium also is a soluble salt. So ammonium positive ion. Sulfide generally insoluble except ammonium. This means that still soluble. Ammonium sulfide. In case of precipitation reaction, okay, a precipitate should form in order for a reaction to take place. If we take a reaction like this, it's potassium iodide plus lead nitrate give potassium nitrate and lead iodide. Which of those salts are soluble and which is insoluble? Potassium in group 1, all group 1 salts are soluble. Here all nitrates are soluble. All group 1 is soluble. Lead iodide, this is insoluble salt. Going to the solubility table, you will recognize that iodide is soluble, but lead iodide is insoluble, so it's solid. To balance the equation, I'll put here 2 to balance I, and nitrate, it's here 2, so I put here 2. Okay, now the equation is fully balanced. Sometimes you are asked to write a net ionic equation. Net ionic equation, very simply, write if a solid is formed, so write the ion that forms that salt. This will be enough to write a correct ionic equation. So lead iodide, so I have lead positive ion, you get the valency from here, plus iodide negative ion, it lies in group 17 and has a valency of 1, form lead iodide, PbI2. To make it balanced, put here 2. Aqueous, aqueous, and this one is solid. In another equation between potassium carbonate and nickel chloride to form potassium chloride and the nickel carbonate. And you are asked to write full ionic equation and a net ionic equation. First, you should check solubility. Potassium in group 1 is a soluble salt. Nickel chloride, all chloride salts are soluble except lead and mercury and silver, and nickel is not in the exception, so it's soluble salt. Potassium chloride is a soluble salt. Nickel carbonate, because most of carbonates are insoluble, nickel carbonate is an insoluble salt. Okay, the second step, you need to balance your equation. Okay, and nickel chloride, I have here 2, we'll put 2. Potassium becomes 2. Now your equation is balanced. Let's write first full ionic equation. You might be asked to write full or complete ionic equation. Complete ionic equation. K2, I am going to write 2K plus CO3 plus nickel. How to know the valency of nickel? It's a transition method. You will get its valency from here. 2 plus Cl, give 2K plus 2Cl plus nickel carbonate. Don't forget that the solid or the precipitate never make ions. And then we should cancel out spectator ions, the ions that are not used. We have potassium here and there, and also we have chloride. Yes, that's correct. So the net ionic equation will be as follows. Carbonate, negative ion plus nickel, positive ion, gives NiCO3 solid. This is the net ionic equation. Let's start in answering the questions. Describe what happens to anions in a double replacement reaction. What happens? Anions change places. So if you have a compound AD plus CB, cation don't change place, still A here and C there, while anions change their place. They swap the position. Second, describe the result of a double replacement reaction. Okay, if it produces two different compounds, if reaction is happening, two different compounds, one of them should be a solid or a liquid or a gas. Write balanced equation for the following reaction. Aqueous lithium iodide and its aqueous, plus aqueous silver nitrate, nitrate, to produce solid silver iodide and the aqueous lithium nitrate. You should write the state symbol and you should balance the equation. It's already balanced. All the ions are in ratio 1:1. It's already balanced. You need to make sure that you are writing the correct formula by looking for the valency. Okay, I'm going to summarize quickly here the valency rule. If you are looking in the periodic table, elements are organized in 8 groups, okay, excluding the transition metals, because transition metals don't have fixed valency. The valency follow the rule, which is follow the group number from 1 to 2 to 3 to 4, and then -3, -4, -2, -1, and 0. So if you have an element in group 1, it should have a valency of 1. In 2, it has a valency of 2, 3 and 4. 5 Okay, 6, 7, and 8. Or according to the table we have, it will be 13, 14, 15, 16, 17, and 18. Okay. Aqueous barium chloride. Barium chloride. Barium, looking at the periodic table, barium is in group 2 and Cl is in group 17. So the formula will be BaCl2 plus potassium carbonate, K carbonate CO3. Carbonate has a valency of 2, so I should write 2 here, while potassium in group 1 and has a valency of 1. The salt will be KCl plus barium carbonate. KCl is an aqueous solution, while barium carbonate is solid. And now the equation is balanced. A reaction occurred between hydrosulfuric acid H2S with aqueous solution of iron 3 bromide. Iron 3, so I will write 3 here, bromide Br, and Br has a valence of 1 due to its possession in group 17. The compound formed will be solid iron 3 sulfide, so FeS, iron 3. Iron has a valency of 3. Sulfur in group 16 has a valency of 2. Plus aqueous hydrogen bromide. You need to write the state, okay, and also you need to balance the equation. Looking at the equation, you recognize that I have Br, 3Br on the left side, so I should put here 3. For sulfur, I have 3S, I will put here 3. Fe2, okay. Looking again, you will recognize that hydrogen, I have complete each of the following chemical equation by writing the formula of each product. Its state, symbol, and balance the equation. First question, NH4Br plus KOH. We said the cation, the formula should start with a cation, which is a positive ion. So the positive ion never change its seat, while the negative ion is exchanged. So NH4 is going to take OH and K is going to take Br. But because NH4OH is unstable, so quickly it dissociates into NH3 and water. So the result will be NH3 plus H2O plus Br. Second question, calcium iodide plus Na2SO4, sodium sulfate. Also don't change the position of the cation, and the anion exchange it. So Ca will take SO4 and Na will take I. Okay, remember that these two is the valency of calcium. Here we don't need to write any subscript because both of calcium and sulfate are divalent and they are going to cancel out. Here also sodium is monovalent and iodine also is monovalent, so no subscript to be written here. The final step is to balance the equation because I have here 2 iodine, so I'm going to put here 2 and making sodium also 2, so now sodium and iodine are both balanced. To put the state symbol, ammonia is gas, water is liquid, KBr is an aqueous solution, NaI aqueous solution, and calcium sulfate is a solid. If you're not sure, go to the solubility rule and check your answer. Similarly, we are going to complete the rest of the equations. Here all equations have been done. Don't forget to write the state symbol and balance the equation to make sure that you are earning the full mark. Following question: a student mixed aqueous solution of iron 3 chloride, FeCl3, and sodium hydroxide, and a precipitate was formed and a colorless solution. A student sketched the diagram and you are asked to answer questions A and B. Question A: write balanced chemical equation with state symbol. Chemical equation, he said iron 3 chloride and he gave the formula. Thanks for that. And sodium hydroxide. What will be the answer? We said don't change the position of the positive ion and exchange the negative ones. So Fe will take OH, Na will take Cl. You need to check for the correct formula. If it's iron 3 chloride was here, so also iron 3 hydroxide will be formed. So the formula will be FeOH3. Sodium is monovalent as well as chloride, so the correct formula of sodium chloride is NaCl. What's left is to balance the equation. We have on that side 3Cl, we put here 3, making Na3, put here 3, and OH became also 3. The last step is to write the state symbol. Iron 3 chloride is aqueous, and this is mentioned in the question. Sodium hydroxide is also aqueous, and you know that from solubility. All group 1 salts are soluble. A precipitate formed, as he said, a precipitate was formed, so this one is precipitate. NaCl is an aqueous solution. This question is asking to write net ionic equation. To write net ionic equation, very simple, look at the solid which is formed in the reaction and construct your equation. Iron plus hydroxide ion forms iron 3 hydroxide. This is the net ionic equation. A student mixed aqueous solution of iron 2 chloride, FeCl2, and potassium hydroxide, KOH. He noticed that a precipitate was formed and a colorless solution also formed. Students sketch the diagram below. Answer questions A and B. Write balanced chemical equation for the reaction with the state symbol. Iron 2 chloride, FeCl2 plus KOH. What's going to produce? We said we don't change the position of the cation. So the cation doesn't change its place. The anion will. So the K is going to take Cl and Fe will take OH. What's left now is to write the correct formula for those two new compounds. He said iron 2 chloride. So the valency of iron is 2 and the OH has a valency of 1. So the formula will be FeOH2. KCl, K is in group 1, has a valency of 1. Cl in group 17 and has a valency of 1. So the correct formula of potassium chloride is KCl. What's left is to write the state symbol and balance the equation. We have here 2Cl, so I'm going to put here 2, making K2, put here 2, and the OH is 2. This is aqueous solution, aqueous solution, aqueous solution, and this one is a precipitate. How do we know? He said here a precipitate was formed and a colorless solution. And you know that all group 1 salts are soluble, so it should be only FeOH2 which is solid. This question is asking to write the net ionic equation. Very simple, you can write the net ionic equation if you know which solid is formed. If you have that solid, so very simply you can decide that Fe ion get mixed with OH ion to form FeOH2. This is the net ionic equation. To answer this question, here a student has 3 different bottles, X, Y, Z. Bottles lost their labels. The student was informed by the teacher that bottles contain 3 chemicals in no specific order. Those chemicals are potassium carbonate, K2CO3, and hydrochloric acid, HCl. The third one is calcium nitrate, but we don't know which one is which. The student performed a different experiment recorded here in the table, and of course he's asking what is X, Y, Z. If according to the data here, if he took solution of X and mixed it with Y, a precipitate was formed. So let's look here which 2 salts or 2 ions that can mix and form a precipitate. You will know that if you get back to the solubility table. You will know that if potassium comes with any other salt, it will be soluble. If H comes with any other salt, it will be soluble. Only calcium carbonate is insoluble. So X and Y, one of them is calcium nitrate, and the other one is potassium carbonate. So at least now we have an idea that this K2CO3 or CaNO3, and the same guess is applied for Y also. For Z, when he mixes X with Z, of course Z will be the one which is left, HCl. When he mixes Z with Y, gas produced. When gas can be produced, if a carbonate is added to an acid. If any carbonate added to an acid, a gas is produced. If Z is an acid, okay, and if he add Y to it, a gas produced. This means that Y should be carbonate. So Y will be the carbonate salt, and the other salt will go to X.